Hi, welcome to lesson 3 of binomial expansion. Today we are going to learn the general term formula. This is the general term. Now we will make use of the general term formula to do question 1 and 2. And then I will also do a revision of what we have learned in lesson 1 and 2 by attempting question 3. Without further ado, let's start with question 1. Question number 1. Find the 20th term if 1 plus x to the power 40 is expanded in ascending powers of x. Now for this particular question, we can use the general term formula. There's no need for us to expand this up to the 41st term, or at least up to the 20th term. Now this is the general term formula, but before that, let me explain to you. Now look at this. This is NC1, NC2 and so on and so forth. So there should have an NC0 here, but it's always being left out, and there's always, here is supposed to have an NCN, but it's also always being left out because NC0 is 1, NCN is also 1. Now you look at this. This is actually the first term. This one is the first term. First term. This is the second term. Alright, and this is the third term. The thing to take note is, you see, when NC0, when it's 0 is the first term. NC1, when this is 1, this is the second term. When it's 2, this is the third term. So when it is R, this becomes the R plus 1 term. Alright, so the general term formula for T R plus 1 will be this part. Alright, you don't need to remember because this whole formula is given in your formula sheet. You must learn to recognize which term is the general term formula, and this is the R plus 1 term. So this is N R A R N minus R times B to the power of R for this expansion. Now once again, I say again, now when this is R, it's actually the R plus 1 term. So now back to this question. They want term 20. So it will be T20. Now, so when it's 20, your R will be 19. So will be 40 C19, then 1 to the power of 40 minus 19, and x to the power of R. R is 19. Alright, so your final answer will be 40C19 times x to the power of 19, because this part is being left out because 1 to the power anything is still 1. Alright, so this is your final answer. Of course you can key this into your calculator, but this is will be an extremely large number. I think it's okay for you to leave the answer just like that. Okay, now let's move on to question 2. Question 2. Find the constant term of this expansion. Now first of all, what is a constant term? Sometimes the constant term is also called the independent term, or independent of x term. Now constant term means it's a constant. It must not have any variable. That means there's no x inside the term. If you expand this, alright, x is the variable. So they want a term that it doesn't have the x, like it's just a constant. Now when they say independent of x term, independent means it stands alone. It doesn't depend on x. So that term must not have x. So it's the same thing when I say constant term or the term independent of x. Now, what is the power of x in this constant term? Now, it cannot contain x. So x has to be power of 0. Because when x is to the power of 0, anything to the power of 0 is 1. So the x must be to the power of 0. It cannot take any other powers. Now, we are going to use the general term formula to help us in this question. So let me write down the general term formula. TR plus 1. Now this is the general term. This is the R plus 1 term. So it's NCR A to the power n minus R B to the power of R. So I just fill in n is 21. I do not know which term will give me the constant term. So leave it as R. My A is 2x. 21 minus R. My B is minus 1 over x squared to the power of R. Now, you want independent, all right? That means the term is, the x must be to the power of 0. Now, you look at this. What are the resultant powers of x? This one will give me, look at just this term. This term will give me x to the power of 21 minus r. And how about this? This is x to the power minus 2r, because 1 over x squared. 1 over x squared is x to the power minus 2. So you times the r is x to the power minus 2r. So x to the power minus 2r. Now you can use a law of indices. All right. So this one will give me the part. Just consider the okay, never mind. I just put the x first. Some of you may be confused, huh? So this is 21 minus 3r. You want constant term. So the constant term is x to the power of 0. So this is equals to 0. Okay. So I have 21 will be equals to 3r. Alright, so r is 7. Okay, so you want to find the constant term. You need to find the coefficient. Alright, so that will be, the constant term will be 21 C7. Then over here will be 2 to the power of 21 minus 7. Then minus 1 to the power of 7. So your answer will be 21C7, and this is super huge. 2 to the power of 14. Now, minus 1 to the power of 7 is minus 1. So your answer will be negative of this. Yeah. Let's move on to question 3. Question 3. The coefficient of the x squared term in this expansion is minus 3, and you are asked to find the value of k. Now if you expand this term here, 1 plus kx to the power of 9, you have 10 terms. And if you expand this 1 minus x to the power of 4, you got 5 terms. But we don't need to expand all the terms. Now let me show you why. Now let me write down this 1 plus kx to the power of 9. Now if you expand this term, you got 10 terms. Now so we start by doing the NCR term first. So 9C0 followed by 9C1 followed by 9C2. Alright, so on and so forth. We stop here. Now then you have 1 to the power 9, 1 to the power 8, and 1 to the power 7. Then you have kx to the power of 0, kx to the power of 1, and kx to the power of 2. Now, the terms after these will have the power of 3 or higher. Okay. Now, just bear in mind with that first. Okay. Now, let me try to expand this term. So you have 1 minus x to the power of 4. Same thing, we do a 4 NC, we do the NCR term first, followed by 4C1, followed by 4C2. Alright, you have 1 to the power of 4, 1 to the power of 3, 1 to the power of 2. Then you have minus x to the power of 0, minus x to the power of 1, and minus x to the power of 2. So on and so forth. Now the next two terms will be to the power of 3 and to the power of 4. Now imagine all these terms has powers higher than 2. So you multiply with any of these terms here. The result will be, they will have the powers of x will be higher than 2, because the lowest one here is x to the power of 0. Alright, then the lowest here is x cubed. Alright, x cubed times x to the power of 0, you get x cubed. Okay, now likewise for here the lowest power after the x squared will be x cubed. Now x cubed, you multiply with any terms here, the power will be higher than x cubed. So we can stop the expansion here. Okay. Now you look at this, when this is multiplied by this, okay. Now which one will give you the x squared term? This and this will give you the x squared. Okay. These two will give you the x squared. This is independent of x, and this is x squared. And this one will give you an x squared. Okay. Now let us multiply the x squared term. So start off with this multiplied by this is 1. Alright. So you are left with 4c2. This is 1 and this is x squared. Now how about the second one? This is 9. So 9kx. Now what is over here? Here is 4. So minus 4x. Now we are left with this term. So this is 9c2. And this is kx squared. And this is 1. Now your coefficient of x squared in this expansion is minus 3. So you got minus 3 x squared. So cancel off all the x squared term. 4c2 is 6. You can press the calculator to verify that. Here you got minus 36k. And this one you have 36k squared. No, this should have a, you multiply, yeah, it should be the square should be outside, huh? So you got 36k squared. 36k squared equals to minus 3. Now we rearrange this, you have 36k squared minus 36k. Bring this over, you have plus 9 equals to 0. Divide by 9 throughout, you got 4k squared minus 4k plus 1. Now let's try to solve this. You look at this. This is a perfect square. So you got 2k minus 1 squared is equals to 0. And k is equals to half. Okay, we have solved question number 3. Now we have come to the end of question 3. Please look out for our videos, and if you like our video, please press the subscribe button. We hope to see you again. Thank you.